So again, we're on page 17. And the first thing we're going to look at is this idea of what we see from standard form versus what we see from factored or intercept form. So we looked at this for vertex versus standard form. Now we're looking at this for standard versus intercept form. So we know from standard form that constant term at the end, that C value, is our y-intercept. And then we also know that that A value, our lead coefficient, tells us some information about the shape of our graph. Do we open up or down? Am I stretched or compressed at all? For intercept or factored form, and I'll use these terms interchangeably, we're still going to have an A value. For everything we looked at yesterday, our A value was 1. It'll be 1 again for every problem that we see that we have to write in factored form for today. And then we took a look at, with one of our examples, what those numbers inside our factors represent. And we said that they actually represent the x-intercepts on our graph. We're going to see the term x-intercepts. You may also see, when we're on our calculators, the term zeros. You may also see roots. And in our next unit, we're going to talk about solutions. A lot of the time, we use these terms sort of interchangeably. And they don't always all mean exactly the same thing. But when we talk about x-intercepts and zeros, those terms are used pretty interchangeably. If I'm looking for x-intercepts on my calculator, as we saw last time, our calculator calls them zeros. You may also, in our next unit, again, start to see the terms of roots and solutions thrown out as well. And they're all talking about basically the same thing, which are these values that I get from my intercept or factored form. So the first thing that we're going to look at today is converting from factored form back to or to standard form. So this is going to be really similar to when we went from vertex form to standard form and we had to distribute. Same idea here. So if I look at example 1 on page 17, I've got my factored form here, my intercept form, and I'm going to distribute. So x times x gives me x squared. And then x times negative 3 is negative 3x. 2 times x would be positive 2x. And then 2 times negative 3 gives me negative 6. I want you to be careful with your distributing. What I've seen over the last few days is people distributing parts of our problem, but not all of our problems. Remember, when we're distributing, I want to take this first term in my first factor and multiply it by everything in my second factor. And then I come back here and I take the second term in my first factor and multiply it by everything in that second factor. Okay, so everything in here gets multiplied by everything in here. And make sure I distribute completely. And then for standard form, I need to combine like terms. So my standard form function would be y equals x squared minus 1x minus 6. So there's standard form. Remember, my y-intercept comes from standard form, so negative 6 is my y-intercept. And then my x-intercepts come from factored form or intercept form. And then just like with our vertex form, if this were my vertex form equation, my vertex would be negative 2, 4. We change the sign on the value in parentheses of x. The same thing happens when we pull our x-intercepts out of factored form. So my x-intercepts would be negative 2 and positive 3. Questions for me on that first example? Example 2, same idea. We're going to distribute. And we saw a couple problems when we were changing from vertex form to standard as well, where we had that A value that was not 1. So just like I did for vertex form, I'm going to distribute these guys first. So that would be x squared minus 6x plus 4x minus 24. When we were converting from vertex form, we had an example like this, and I combined like terms before distributing that A value. You don't have to do that. You could distribute the A value and then combine like terms at the end. I'm going to show you that option for today. If you wanted to clean this up first, that's also fine. You're going to get the same final standard form. So when I distribute here, I've got negative 2x squared plus 12x minus 8x plus 48. And then don't forget, for standard form, I need to combine those like terms. So I would have negative 2x squared, combine my like terms there, and I get plus 4x plus 48. My y-intercept is 48, and my x-intercepts are negative 4 and positive 6. Questions for me on example 2? Okay, I want to make one quick comment about how you guys write your x-intercepts when I ask for them. It's okay to list them with a comma in between. And for most of our remaining problems, this is probably how I'll write most of them, just based on the space that I have on the paper. But what I see every once in a while is that people slap some parentheses around. This is no longer a list of x-intercepts. As soon as you put parentheses around those two numbers separated by a comma, this is now an ordered pair. And you are telling me about a specific point on the graph. This is not an x-intercept. This is a point, right? Would go roughly there on the coordinate plane. So I'm going to be picky about this. If you put parentheses around it, you've given me a point, not an x-intercept, okay? So listing it with a comma between, absolutely fine. Do not put parentheses around there because you've changed the meaning then. Now you're giving me a point, okay? And again, I am going to be picky about that. Questions about that? Okay, let's go ahead and move on to page 18. We're going to do some more practice changing from intercept to standard form. So we've got a table up at the top where we're going to have intercept form, standard form, and our x and y intercepts. So in order to get standard form, I need to distribute from intercept form. So this would be x squared plus 3x plus 2x plus 6. Remember, for standard form, I need to combine like terms here. So if you're writing with a pencil, you can erase right here and write 5x, 3x plus 2x would give us 5x. Since I'm using a pen, I'm just going to write plus 5x over the top here. My x-intercepts would be negative 2 and negative 3. My y-intercept is 6, positive 6. Now we're going to do the same thing for our next problem here. Distribute to get standard form. So I would have y equals x squared plus 5x plus 3x plus 15. And then I want to combine my like terms in the middle there. 3x plus 5x would give me 8x. So plus 8x in the middle. My x-intercepts would be negative 3 and negative 5. My y-intercept is 15. I would like you now to try the remaining two problems that are given to us in intercept form. Change them to standard form, identify our x and y intercepts. For our third function here that I distribute, I would get x squared minus 6x minus 3x, so that would be minus 9x, and then plus 18. Our x-intercepts are positive 3 and positive 6. Our y-intercept is 18. For our last function that's already in intercept form, to get standard form, again, we're going to distribute. So we have x squared minus 3x plus 2x. When I combine those, I get minus 1x. And then 2 times negative 3 would be negative 6. My x-intercepts are negative 2 and positive 3. My y-intercept is negative 6. Questions on either of those functions? Okay, next we're going to take a look at converting from standard form to intercept form. So we're going to factor, just like what we did yesterday. So if I take a look at my first function that's given in standard form, to write this in intercept form, we need to factor. So we need to know what factors of 14 add to 9. So what would multiply to give me 14? So if I added it, I'd get 9. 7 and 2, yeah. If you need to make a list, you can. But 7 times 2 would give us 14. 7 plus 2 would give us 9. So our factored form here would be x plus 7 times x plus 2. Since we wanted positive 7 and positive 2, that's what I see in my factors. X plus 7 times x plus 2. My x-intercept then would be negative 7 and negative 2. My y-intercept for this function is that c value from standard form, which for this problem is 14. Now I'm going to do the same thing for our next problem. I want to know what factors of 12 add to 7. 3 and 4. So this would be y equals x plus 3 times x plus 4. My x-intercept then will be negative 3 and negative 4. My y-intercept is 12. And then one more in our table here. This is a little bit trickier problem because I don't see that middle term. I don't see that bx term. We saw one like this that we looked at together yesterday. So remember, we could rewrite this as x squared plus 0x minus 25. If I don't see the middle term, it's because my b value was 0, right? I have 0 x's. So I want to know what factors of negative 25 would add to 0. Negative 5 and positive 5. I want the same number but opposite signs. So my factored form here would be x minus 5 times x plus 5. My x-intercepts would be positive 5 and negative 5. And my y-intercepts would be negative 25. Questions for me on any of our problems from the table at the top? Okay, so we have a few more questions, but we're going to look at changing them into intercept forms. We've got standard form right now. We're going to change them into that intercept or factored form, which means we're factoring again. Okay, so same idea as what we did in the table, same idea as what we worked on last time. For example 3, I want factors of 12 that add to 8. 6 and 2. So 6 times 2 would give us 12. 6 plus 2 would give us 8. So this would be x plus 6 times x plus 2. Is our factored form. How about, for example 4, factors of 18 that add to 9. 6 and 3. 6 times 3. So this would be x plus 6 times x plus 3. just a reminder, if you don't see those factors that you need right away, some people are really great at identifying the factors that they need from a particular number. It's almost like it's already written on the paper for them. Some people need a minute, takes them a little longer, and that's okay. If you are struggling to identify the factors that you need, remember that strategy we talked about last time, make a list. So if I didn't identify 6 and 3 right away, if that didn't pop into my head, then what I want to do is make a list. Remember, go in order. So 1 times 18, or -1 times -18, and then 2 times 9, or -2 times -9, 3 times 6, -3 times -6. I can't evenly divide 18 by 4, so I would skip 4 and 5. The next thing I could evenly divide 18 by would be 6, and I already have 6 listed. So the rest of the factors I could write would just be repeats of what I already have. So make a list, go in order. Once you've got your list done, look for the factors that you need. So this would be 3 and 6, which I know we had already, but if you get stuck, remember, make a list, okay? Let's take a look at number 5. This time I want factors of -18 that would add to +3. 6 times -3, good. So this would be y equals x plus 6 times x minus 3. And then our last problem on page 18, factors of -8 that add to +2. Go ahead. 4 times -2. So this in factored form would be x plus 4 times x minus 2. And just as a reminder, I know we talked about this last time, if you wrote this in the opposite order, so you had x minus 2 times x plus 4, these mean the same thing. Remember, for multiplication, the order doesn't matter. 2 times 3 is the same as 3 times 2. That's also true with our factors. If I distribute these, I get the same thing. Okay? Questions for me on page 18. Okay, go ahead and turn to page 19. And I would like you to try now problems 1 through 4 on page 19. So same thing we just worked on, but this time we're adding in identifying those intercepts. Okay, let's take a look at our problems on page 19. Number 1, I want factors of 8 that add to negative 6. What are the factors that I want? Negative 2 and negative 4. So my factored form would be x minus 2 times x minus 4. My y-intercept is 8, that comes from standard form, and my x-intercept would be positive 2 and positive 4. For number 2, factors of 12 that add to negative 7. Negative 4 and negative 3. So my factored form would be x minus 4 times x minus 3. My y-intercept comes from standard form, that's 12. My x-intercepts would be positive 4 and positive 3. Questions on 1 or 2? Okay, for 3 and 4, same idea. For number 3, I want factors of negative 6 that add to negative 5. Negative 3 times negative 2 is a great guess. What's the problem with negative 3 times negative 2? If I multiply those, what do I get? Positive 6. So I will tell you that the problems I see the most errors on are problems where we have to factor 6. For whatever reason, we have a hard time with the 6. Okay. So you have to be careful with your signs on this, because I will see a problem like this factored like this all the time. Okay, really, really common error. What do I want instead? 1 times 6, but I want these to multiply to negative 6. Yeah, I need the 6 to be negative here. So these would multiply to give me negative 6. If I added them, they would give me negative 5. Okay, for whatever reason, the 6 ones are hard. So we would get x plus 1 times x minus 6. Our y-intercept from standard form is negative 6. And our x-intercept from factored form would be negative 1 and positive 6. Questions on number 3? I'm glad you said this, because that gives us a chance to talk about it. How about number 4? Factors of negative 10 that add to 3. Factors of, got to be 2 and 5. But to get negative 10, one of these needs to be negative. 2. Yep, 2 needs to be negative. So this would be x minus 2 times x plus 5. Our y-intercept from standard form is negative 10. And our x-intercepts from factored form would be positive 2 and negative 5. Questions for me over anything from page 19? Okay, so for the rest of our class time, you should be able to get this done in class. I want you to work on page 20. Whatever you don't finish from page 20 is your homework. You have 6 more problems, same idea, factor, give me that intercept form, and then identify your x and y intercepts. So page 20 is your remaining work for today.